Once you have the basic tools of construction, it's pretty easy to make a lot of different shapes. Now you are going to have to think of these shapes, even simple shapes, as the sum of their parts. So when I'm looking at this first construction that I want to do, I'm going to try to make a square with the side length below. And I know that I can just kind of like eyeball it, move these over, and try to find something that's approximately a square, but that's not going to be good enough. I need to make something that is constructed perfectly. So we have like exact 90 degrees, all the side lengths are the same to make sure that it is actually a perfect square. So when I'm trying to break down a construction that's confusing me, what I'm going to do is I just list out the things that I know how to do with construction and see if they can get me one step closer to having a perfect square. So here are the things that we've talked about thus far. We know how to copy a segment or its length. We know how to copy an angle. We know how to bisect angles and segments, like cut things in half. And we also know how to make perpendicular lines. And when I look at that, I think to myself, well, okay, really what I'm going to need to make sure first is that I can figure out how to get a 90-degree angle here. Because if I don't have a 90-degree angle, then it's definitely not going to be a square. Well, in order to have a 90-degree angle, the only thing that I have with that is really perpendicular lines. And I know I can make a perpendicular line. So what I'm going to do is I'm going to make a line perpendicular to this segment. That opens up actually a new problem. Let me start by just drawing in 2 points on this segment, A and B, just so we have something to work with. Now I want the perpendicular line to come through here. And when I think about like how I make a perpendicular line normally, I actually come through at the middle of something. So what I'm going to have to do is I'm going to have to extend this segment just a little ways out. Like, yeah, my final square will have this as its segment, but for now I might need to like extend this down so that A can come at the center of my line, and that way I'm going to be able to make my perpendicular line going through the point A. So what I'm going to do next is I'm going to just find the perpendicular line that hits at A. Remember that we did this by taking our compasses, placing them on the point where we wanted that 90 degrees, and picking a random setting on our compass. And what we're going to do then is, once we have that setting, go ahead and make a line, like a marking on either side of that point, so it looks something like this. These 2 points are not going to be part of our square, right? Because like this AB is part of our square. But I'm going to use these 2 points, and I'll just call them X and Y for now, to bisect this segment using a perpendicular bisector. Remember that when we did this, all we had to do was put our compass on one of our found points. We like to just match it with our other found point, though really anything past the halfway point of this line will work. And I just kind of swirled that around so that I have my first half circle. Then I flip this over to X, my other found point. I go back to Y, and here we have the markings for perpendicular bisector that goes through A. Now what I'm going to be able to do is I'm going to be able to, with my pencil still, sketch in this next segment. Now I'm going to then be able to know that this is hitting at exactly 90 degrees because I've made something perpendicular. But what I want to make sure of next is that I don't extend this too far. In order for this to really be a square, it needs to have the same length as A and B over here. So what I'm going to do is I'm just going to find the length from A to B. And I found my setting here, and I'm just going to drop that length over here. Because I now know that from A to B will be the same as from A to this new point, C, and I know that this is coming at 90 degrees. And that will give me 2 of my sides of my square. In fact, I'm going to just darken those sides in red so that it's a little bit easier for me to remember where my final figure is and what are just extra points. So So at this point, I'm not going to clean this up too much because I want to keep my work shown for this, but at this point you really can get rid of all markings besides A, B, C. Then what I'm going to do is I want to construct the rest of my square. Now the process really hasn't changed because what I ultimately want next is a 90-degree angle coming through at C. So I can repeat my process from above to find that 90-degree angle. I'm going to put the center on C. I'm going to find 2 points that I'm going to then be able to bisect. The segment formed, I'll just call them X and Y again because those previous points were erased. And what I'll then be able to do is taking X, going to Y, I can go ahead and make another perpendicular bisector. Because these points are equal distance from C, when I make my perpendicular bisector, it will pass directly through C at 90 degrees. Once I have this, I go ahead and connect those to C. And at this point, I now have my next part of my square. I can then just make sure that I'm going to get the consistent length by placing my compass back on C, copying the original length, or in this case, I'm just going to copy the length of AC and bring that on over to this line. So I found the setting on A, I spun it on over, and that gives me my new point D. Here, yes, I could construct a perpendicular bisector, but I know that B and D have to connect if this is a correctly drawn square, and all of these will end up being 90 degrees. I would darken this with the rest of my pens, and I would be set with a perfect square. Next, we're going to look at how to do an equilateral triangle with a given side length, and this is one that we actually did do together in class pretty much exactly. So what I'm going to do in order to find this is first just find the perpendicular bisector. We know that that can be found just by finding your 2 endpoints and doing a half circle around. Over here, I'm going to just reverse, match up my settings. So I'm using, again, that same endpoint. And at this point, I now have this 3rd point. Now notice something interesting about this point. I know that this is the same setup for perpendicular bisector, but I actually don't need the perpendicular bisector. I need an equilateral triangle. Well, in an equilateral triangle, we know that all the lengths of the sides are the same. I have taken the side and rotated it this way. I've taken the exact same side and rotated it this way, which means that any point on these circles is equal distance from the endpoints of my segments. Where these 2 meet then is the point that those 2 have in common, meaning because this is the radius of this circle, it's equal to this line, and because this shares a radius with this line, it's also equal. That creates an equilateral triangle. For the final one that we're going to do together, we are going to look at how to make a 45-degree angle. This is another one of your challenge problems. Now with this, I'm going to just check my skills because starting it is maybe a little bit hard for me. I can copy a length and an angle, but I don't have a 45-degree angle listed, and I don't have a length. Well, that's not going to help with an angle. I can cut things in half, which might be helpful, and I can make a perpendicular line, so I can make things at 90 degrees. And when I see that, okay, I have 90 degrees. I can cut it in half, and that will actually give me 45 degrees. So let's go ahead and do that. I'll start by making a 90-degree angle and cut it in half. So in order to make a 90-degree angle, all I need to do is go ahead and make for myself a line segment. From here, I can find the perpendicular bisector of it. I'm going to just extend a little bit past halfway. I don't always need to use the endpoints in order to do that, as long as I can keep my setting the same so I don't lose my setting on here. I can just go ahead and rotate it over to my other endpoint. And I'm going to just extend this over and up. There we go. So now I have what I need to create that 90-degree angle. I know that what I've just made here is a right angle. And now that I have this right angle, I can cut this right angle in half, and it will have to be 45 degrees. In order to cut an angle in half, what I'm going to end up doing is I'm going to start by drawing a circle, just any random setting, and cutting it through that 90-degree angle. I've created 2 new points, and try not to get too confused by the extra ones. You can always get rid of these extra circles once you're done with your original task, like getting that 90 degree, but I'm going to leave them for now. I'll call these 2 X and Y. Then what I'm going to do with X and Y is I am just going to make a circle around Y and a circle around X that both have the same radius. Again, I personally like to just use X for my radius and Y for my radius. They're very close too. And I'm going to make this one a little bit darker just because I have a few circles going on here. Then I'm going to do the same thing with X to Y. And again, just making it a little bit darker just because there are a lot of circles going on. With these 2 circles I've just drawn, these slightly darker ones, what I'm going to do is I'm going to connect my intersection points. And what I've found with that is a bisector of my 90-degree angle. This angle bisector then has created 2 45-degree angles. Now, since the problem only calls for 1, what I can do at this point is I can outline this in black pen and erase all my pencil marks to have a very nice and neat 45-degree angle.